Hello, hello everyone. It's Jonas with Tezos.community. We're moving on to part 3 of the epic technical meetup that we hosted in Menlo Park. Arthur and Jill from the foundation did a great job talking about the Tezos platform and about a lot of issues that are important to the community. So here's part 3. We hope you enjoy it, and we'll see you soon online at Tezos.community.
Okay, so here.
Do you have plans for specific smart contract standards, kind of like how Ethereum has ERC-20?
Yeah, so despite everything I say about about tokens and so on and so forth, I do think there's many cases where you do want to have sub tokens. Like one very clear one is, let's say that you're tokenizing some external assets. So there's some investment funds like real estate investment funds which are starting to take like shares in their fund and actually put them on the blockchain. And I think that's like it's not there's no idea of like this token like powering smart contracts or anything like that. But I think it's a very valuable service. There's many places in the world where you really don't have access to any vehicle to invest. And if you can have a small ticket price and like for $10 you can invest $10 for with transaction fees in the pennies, and then all of a sudden you own a share of like a diversified real estate trust around the world. That's fantastic. So that's the case of a sub token that I think makes complete sense, for example. Or if you're like a company with an existing user base and you want to have your own token for your existing community, that also makes complete sense. I think what doesn't make sense is models which are as a forum. We'll have a token, and this token will be the token that people use to pay for XYZ. Because in some sense, you're just saying like, well, why don't they use a base token for doing that? And so yes, in that respect, so there's two possibilities. If you look in the history of the Tezos code base, you will find that it had at some point the idea of asset issuance, where you could have named assets and they could be issued by a contract, and then they would be treated the same way as other tokens would be treated by the contract. So one of the benefits of this, as opposed to something like ERC-20, is that all of the accounting of transactions and so on and so forth is done directly by the protocol, as opposed to be interpreted through a virtual machine. So that's a big benefit. So that would be one way of like having tokens. Get the concept of a token really at the protocol level. One of the advantages of ERC-20 as opposed to that is that ERC-20 kind of wraps the transaction type you can make. They can add conditions for like whenever you want to transfer something. Like they could add like a transaction fee. They could add like some condition that you prove that you've done some identity verification before making a transaction. So it is interesting to have this model. Maybe we can do a hybrid of both, where the tracking of tokens happens at the network, happens in the protocol code directly, but we let people like add snippets of function if they want to have like side effects when some transactions happen. So yeah, I think we'll have a standard contract like this. We already have a multi-sig contract that we're going to keep working on, because we want to have it's important to have a really nice multi-sig contract. We even did a formal proof on the correctness of the contract we had. So that's nice. I think it's like one of the most important building block you have. A standard thing you can do as well in Tezos is that functions are first-class values. So writing a multi-sig contract where you can just have the signatories just decide on which function, on how to replace like a stored function, it lets you do an updatable contract. So that's a pattern that's very useful. I do think in general that a lot of contracts are just going to be reusing existing blocks. Like there's some situations where you want to write a slightly different contract, but most of the time you're using very fixed patterns.
When you say something happens in the protocol rather than on the VM computation, what does that mean?
Yeah, so the idea is that imagine that we have the concept in the protocol of a token move, right? So you would send a transaction to the blockchain, and the OCaml code that parses out this transaction would say, hey, this is a transaction of a token. So in OCaml, in our internal representation of everything, with compiled code that runs directly on the CPU, we would say, okay, we're going to execute that. Now, in principle, instead of that, you could say, okay, we're just going to simulate that in a smart contract. So now, instead of the protocol running that, the protocol takes a smart contract, interprets a language, and evaluates it. Now, in theory, it should be almost equivalent, right? Because you could say, well, we're going to have a virtual machine for our smart contract execution, and the virtual machine is going to be very optimized. It'll be very fast. You have very fast virtual machines today. And so the overhead of actually doing it in a smart contract as opposed to doing it directly in the protocol would be very small. But I think you lose certain things. First, if you have this very, very fast virtual machine, there's going to be very low level. So you're going to lose some safety properties that you might want to have. And the second thing is that in practice, this is what Ethereum promised, but in practice, like even simple functions, like you want to write your custom hash function with Solidity, you're gonna hit gas limits very fast. So there's always going to be a benefit in like putting it directly into the protocol as opposed to in the smart contract layer. I would say anything that's really like base infrastructure that anyone benefits from will benefit from being moved into the protocol in the long run. So even something like multi-sig is super light because you just like, okay, it checks string, it's basically it's learning to count, right? 3 out of 3 multi-signature, you validate the signature and then you count how many you got. That's fairly simple, but even there, one thing I've been interested in is like integrating multi-sig directly inside the contract. Especially Schnorr signatures can be aggregated, so you can actually have like a single signature that actually represents a multi-sig.
One follow-up on that, if you don't mind. You just made a distinction between the utils and the protocol. So when we talk about like voting on things, is that voting on things to get pushed into the protocol, or is that something about the utils? Kind of what's that distinction?
Yeah, so utils cannot, so it could happen 2 ways, right? It could happen that we decide that we really want to have pairing cryptography, and so we all say like, hey, every node, make sure you have this pairing cryptography library ready, so that in case someone wants to do an update, an update to the protocol, then it'll be ready. Another way to do that would be to like submit a proposal to the protocol, but make it clear that, hey, this proposal will not actually work automatically. You need to add this external dependency, and it's not ideal because I think the automated update process is better. But if it's like, if the update is popular enough, and if the upgrade, if the dependency is not controversial, I think it would be fairly smooth, and it'll be useful in the beginning where we want to add more. When we want to add more dependencies. The benefit of having this automated upgrade mechanism is that we don't have to depend on that. So, by all means, if we can get everyone to make sure that, hey, make sure you install this new crypto library before this date, I think that's fine. If for some reason we're ever in a position where we can't, then we can always implement that library directly in the protocol.
How is Tezos going to achieve scalability, and what do you think of Ethereum's current approaches of like Radiant and Plasma?
So in terms of scalability, so how is Tezos going to achieve scalability? So one of my pet peeves is that when people talk about scalability, they will say that, well, scalability is all about asymptotics, right? And so anytime you have a system where everyone validates every transaction, then that doesn't scale because it's quadratic. And that's not actually true because you don't need anyone to validate every transaction. You need a sufficiently large amount of people to validate a transaction. And so I think it's like constant type n, not n squared. And also in the end, it's like we're still in a realm where before thinking of asymptotics, we should think about throughput, right? If you have something that has the same asymptotics as your current system, but which can do 100 times more transaction, you should be doing this now. So if you look at a proposal like Bitcoin NG, I really like Bitcoin NG. It's a very small change to Bitcoin. The miners are just as well off with Bitcoin NG as they would be without Bitcoin NG. The users just are well off. It just so happened that Bitcoin NG gives you about 100x increase in throughput. And some people will say, well, that's just 100x. That's not more scalable. Well, like, hey, 700 transactions per second is nothing to sneer at. I think Visa at the peak does something like 4,000 transactions per second. So if you get near that realm, it's going to be, sure, it might be interesting to have even higher scale of transaction, but let's get there first. And if you look at the type of of systems that people have in mind. And they say like, well, if you want to have like a Reddit on the Ethereum blockchain, then you want to store on the blockchain every single upvote and downvote, then there's going to be like a ton of transactions. I don't necessarily think that you want to do that in the first place. Like, I think the type of stuff that should go on the blockchain is what state do I need in order to decide if a payment is going to go through or not go through. Right, and so maybe that's a karma of a Reddit vote, but I think a lot of that can be aggregated outside and committed to the blockchain. So I don't necessarily think that a lot of these things need to scale on-chain. Now, longer term, in terms of the algorithm that I really like, my personal preference would be for Tezos to move towards the type of proof-of-stake algorithm which are more in the sense of like, let's have some classic agreement procedure, and then, but have like some rules for slowly changing the validator set. I think it's probably a better bet, and I would like to move in that direction. I know that it's a controversial direction, so I think it'll depend on what the community, the Tezos community as a whole wants to do. I like the option, and one thing that you can do with this option, you can combine that with something like the idea behind Bitcoin and G. So instead of trying to do consensus on large blocks, you try to do consensus on leaders. So basically, you say, okay, you have like a large pool of people, and so the consensus is slow. So, but maybe every hour they agree that, you know what, now you're going to be the person in charge of signing all transactions. And for an hour, it's a centralized system where everyone sends a transaction to one party that just like signs them very, very, very quickly and publish them. And if they ever like try to get funny about it and they will spend or something like that, they lose a huge bond. And then after an hour, there's a new consensus that happens, and all of a sudden, boom, now it's another validator. So I think systems like this, if you position them into like the efficient frontier of how decentralized you are and how efficient you are, they are extremely efficient. They are like about as efficient as a fully centralized system, but they do preserve a lot of decentralization. So I think I like that approach too. But we'll see what other people come up with. Like the idea that I don't need to come up with the next big scaling algorithms. There's a ton of research going on in the space. Like Jill said, we're interested in funding academia, so we're very open to just seeing like what are the best solutions which are out there and putting them through. I think with the existing proof of stake algorithm that we have, we can already have a much higher throughput than most proof of work blockchain. The main idea being that if we have an intertime block of 1 minute, it means that during this entire minute, you can be validating a block. Right? In Bitcoin, the time you take to validate a block needs to be very small compared to 10 minutes, whereas here, you could be validating, as long as you're done before the minute is over, you're good. So, like 10, 100x more transactions per second are pretty doable.
Yeah, earlier you touched upon private chains, and obviously a lot of the banks and financial institutions are really resistant towards public chains. Is Tezos thinking about working with that, financial institutions? Is that one of the possible beachheads for you guys simply because given the securities you guys afford? And also, if that's not, what is your, what do you think might be your beachhead given the fact that Ethereum is pretty dominant in terms of, footprint of the universe of use cases?
Yeah, great question. Thank you. So we're talking to several financial institutions about building on the platform already. So that's certainly one of the beachheads.
Is that public or private chain?
It's still public, yeah. And I think that if you look at the trends in the space, there's been a lot of experimentation, a lot of proofs of concept, a lot of R&D done by financial institutions in both spaces. And I think that different use cases will probably be applicable to different forms of infrastructure and technology. And so, I'm happy to get, further into it kind of offline perhaps of, what the specifics of those areas that we're looking into are and where we're discussing that. My personal take is that, yeah, there will probably be use cases that, as Arthur said, you're going to operate on kind of a sliding scale of where you need really high throughput, low latency, efficiency, but you can handle being in a much more kind of private or permissioned network. And then you're also going to have use cases that do demand a more decentralized model, perhaps still with some kind of permissioning around them, but where you're just talking about sort of, big settlement as opposed to doing like real-time execution of trades, things like that. Then there's also just kind of decentralized storage applications that financial institutions are exploring, of just coming to agreement or consensus that basically everyone is looking at the same data. Those are kinds of sort of more intermediate steps, I would say, towards, you know, more kind of fully transactional model of using the technology. But certainly, you know, financial enterprise is one area that we're talking to. And, you know, given kind of the way that Tezos has been built with this sort of mission critical, you know, enterprise ready kind of software approach, you know, being built in OCaml, you know, having formal verification in mind, and then also a lot of the scalability concerns that Arthur touched on. You know, we think that we bring a value proposition to that ecosystem that as yet has been unmet, even again with all of the great R&D that's gone on in the space over the last few years. I do want to reiterate though that that's just one of many spaces that we're looking into. You know, it's not all just Wall Street and capital markets. You know, things like insurance, again, things like gaming, things even in sort of broader infra, whether that's energy, telecom, et cetera. We've got some pretty exciting balls in the air in all of those spaces, and, you know, hope to continue to see more and more crop up over time. You know, I think one of the really exciting things about this space is that, yes, a lot of the attention has been from Wall Street over the last few years, and it's just now that we're starting to see more and more areas really take heed and find even more exciting use cases for their given industries.
Before we take another one, I'm just going to take, because we have like 2 or 3 left for the website, so if I get them, we'll be able to say that we got them all. Yes. Will Tezos be supporting the Lightning Network? I'll go quickly. Will Tezos be supporting the Lightning Network in Lightning Network development for virtual instant conversion between currencies across different blockchains in the future? So I think we're mostly focused on our own blockchain more than we are about interoperability with other blockchains. I think if people build it, that's great. In general, I like things like the Lightning Network and off-chain scaling. When you have a smart contract platform, doing things like Lightning is much easier. Like Raiden has been around for a while for Ethereum, so it's, you know, definitely something to definitely something we want to happen. Not the immediate focus. Second question: what can a Tezos stakeholder do for marketing of Tezos so that it will be a leading smart contract platform? I think that highly depends on the person. Right now, the best something can do, I think, is if there are developers that try to build application on top, communicate with us what are their pain points. I think one of the highest leverage we have right now is having really good developer tools, which we don't have right now. Like, you know, we're building them, and once we have these very good developer tools, we make it very easy and very painless for people to build these applications. Then I think that will help. So, like, if you can participate in that effort, I think that's fantastic. Third question: what kind of business model can be established on top of the Tezos platform? So I think personally, like, there's a few business models I'm really interested in. One is any business where you basically want to tie your own hands for your customers. So let's say that you're a video sharing platform, and people have followers, and, you know, maybe they get a revenue stream from it. So something like your YouTube, for example. If somehow YouTube decides more to cut your ads, then you're not going to make any money. You could try to move to Facebook, but you're going to lose all your followers. So if instead of that, you can have an open protocol where you can say, hey, this is a completely open protocol. You're going to own your data. You don't store it yourself. It's stored some decentralized storage, but you're going to own your data. You're going to own the graph, like the connection you have with people. We're just going to provide you with a very nice interface. So some sort of like half like public blockchain, half of a private company model, I think can work really well, where you focus on bringing the best user experience to an open protocol. I think that's an interesting business model. Tokenization of traditional assets and putting them on a blockchain so that for financial inclusion, I think is a huge application, and I'd like to see more of that. I think that there's going to be interesting. So, you know, if one way to do this is like to simply go through like regular securities offering. I think that one thing that finance does, one thing that blockchain do is that they can reduce cost a lot. So somehow if you can make this even smaller, like if you could have an application, for example, where you're a songwriter and you release a song, right? So now you could go on Indiegogo and say, hey, I'm gonna publish a song, like fund my song, and maybe I'll sign you a T-shirt or something like that. If you could say, I'm releasing a song, and you get to buy a small piece of the song and get a royalty, I think that's great because you're supporting the song, and every time you hear it on the radio, you're like, hey, I'm making maybe like a fraction of a penny here. So I think there'll be some regulatory challenges around like finding the right model for this to work, but I would be excited to see this. And in general, anything that's like relies on some sort of cross-border payments or any type of cross-border cooperation. Like part of the reasons that the DNS not the DNS system, but like the ICANN and part of the governance around domain names isn't exactly great. And part of the reason is because there's no good really supranational governance model for this. And so blockchain and the decentralized network, I think, are in good position of dealing with this. And then the fourth question, for the financial perspective, how many years at least do you advise to hold Tezos token for the stakeholders for big financial return? I do not. I do not give financial advice. Right.
I have a question on the transaction fee. So you mentioned the song publishing business model.
Yeah.
So if you think of a model where you have a song and it's a per stream, let's say a payment, like a user streams the song, you're talking about pennies.
Right.
So the
fractions of pennies. Yes.
Fractions of pennies per.
I think pennies is what the songwriter makes for a stream.
The question is, so the transaction cost using the Tezos blockchain, how can you anticipate what it will be? Because if you start building a business and you have no control over the transaction fees, maybe your business starts as a viable business and over time becomes a non-viable.
Yeah, so I think that's why the governance model can be appealing, because there's this idea that on the Tezos blockchain you want to be able to like keep attracting those businesses because they bring value to the ecosystem. So you're going to want to try to keep those transaction costs low.
I think I think that if you talk to Spotify or whoever and ask them the same question of, well, how do you deal with it when your users are paying with the credit cards, and don't you worry about credit card fees changing and going up over time? I understand that in this case this is a much more technological problem, but in a way one of the value adds is that if you've built on the network and you have stake in the network, then at least you can feel like you have some say in kind of that, what that model becomes.
To come into the distributed energy, so the stake you have in the network, you have a stake, let's say you're Spotify, but you're competing with other users of the network who may have higher stakes. So if someone is selling homes and someone else is selling streams, you see the values are so disproportionate that maybe you'll be priced out of the market because your transactions are so small that nobody cares and nobody wants to validate your transactions, and they'll be just validating the bigger ticket items.
Yeah, that's possible.
It's a great crypto economic experiment, right?
I mean, I think the answer to that is that ideally you try to build something that's scalable enough where you're going to be able to accommodate a lot of people, and also ideally you also scale. You also do as much off-chain scaling as you can. So I don't think that a royalty payment for like one single song being played of a penny needs to necessarily happen on the blockchain every time, right? So you could have like aggregating services. So for example, when I describe that, a lot of people think that it has to, it's going to be on the blockchain, therefore it has to be this completely decentralized app. Otherwise, it doesn't make sense. Otherwise, you might just have like a single business. But let's say I have a business platform where I do this thing and I collect the royalties and I just pay them out. Maybe I just pay them out monthly to the people. So why not just pay this to them credit card? Well, maybe because your song is actually popular all around the world and you have these people everywhere, and you want to pay them out. So, as a user, when I buy something in this song, I'm not necessarily concerned with the idea that, hey, I really want to have a cryptographic assurance that every time this song is played, I'm going to make pennies. This is not what you're solving for. What you're solving for is, I want the title that I have to this song to be very convenient, right? I don't want it to be stored on some website that maybe can, run away with it. I want to have like this, like, title and be able to control it and send it to someone else if I want to. I want to be able to own it directly. And I think that's what you're solving for more than the actual money distribution system. So I don't see blockchains as actually being a good place for doing like millions of very, very small transactions.
Do you have an updated timeline or time estimate for the LiveNet to be deployed?
Yeah, I'd like to have. So I don't have one right now. I think the closest. I think that the blog post that I wrote, but with a state that said like anywhere between like could be 4 or 6 months, could be more. I think it's still accurate. One thing that we had is that after the basically a lot of developers were completely exhausted after the fundraiser. I think it doesn't look like it, but it was 2 months of really intense development, working weekends and very long nights. And so a lot of them took vacations that were very, very needed. They hadn't been on a vacation for a very long time, and so they're like returning to work and. So that's basically like the project took a little bit of a breather in that time period. So what I want to do is like really get the basically like mid-September I'll really get the team together, go through the entire code base and try to produce an updated timeline. I also think it'll depend a lot on what securities audit might find. Now, to be honest, I think in terms of timeline, the fact that the fundraiser was so successful means that we need to pay even closer attention to the project. I mean, I strongly believe that everything is trade-offs, including security. You could keep spending millions and millions of dollars on security and never be done. So how much you're going to spend on security depends on like what is the level of interest in the project, how many, who are your adversaries, how many people are going to look at it. Tezos is very high profile now. A lot of people are going to be looking at it when it launches. So I think it makes sense to like take a step back and really, really focus on the security before launching. Now, some people will be, when I say that, some people are happy about it. They say like, yes, please take your time. We want Tezos to be great when it launches. We want Tezos to be safe. And then some people are like, how do I transfer my Tezos token to my Ether wallet? We got a lot of those.
Yeah. I mean, our priority is shipping the most secure, scalable, robust network that we can, not getting listed on exchanges, right? So, we're much more focused on that than, publishing very transparent timelines or, making your tokens movable.
How would you compare Vertex Solidity versus like OCaml, and then what's the trade-off?
So in our case, Solidity would not compare to OCaml because OCaml is like it would be more a comparison between like Go and OCaml. OCaml is how the blockchain itself. It would be Solidity and Michelson. So you can think of Michelson as a very low-level, high-level language. It's kind of like Bitcoin script in some sense, but with higher-level primitives and with functional primitives. So we manipulate the stack, so there's not even there's no variables, there's nothing like that, because it needs to be low-level if you're going to do gas accounting. So it works like a virtual machine, but it does things like access an associative map, or hash something, or get a signature. Bitcoin does a little bit of that because you have a Bitcoin opcode, which is check multi-sig, right? And the whole thing is just checking multi-signature. So we're taking that approach of having these high-level components, but we're making them more flexible than what you can do with Bitcoin scripts. The approach that Ethereum took was to do the EVM first, which is like the super low-level virtual machine, and only recently was there a full formalization of the EVM. So now you can analyze like EVM contracts and know what you're doing, and then on top of that, build compilers that target this. So we're much higher level than the EVM, but also lower level than Solidity. Now, in terms of design, Solidity tries to it has this index of JavaScript. It tries to look a lot at JavaScript, and one of the good aspects of that is there's a lot of programmers out there doing JavaScript, and so it's easier for them to pick Solidity, and so it gives them a lot of interest, a lot of people working on it. However, I think it also inherits some of the bad safety properties of JavaScript. So if you look at the parity wallet bug, I don't know those who follow that, but the Parity team produced a multi-sig wallet. There was a bug, and the bug is very simple. There's an init function in this, which you call, which normally is called to change the owners of the wallet. It's called internally because the way it's designed is that the multi-sig owners can decide by multi-signature to change who the owners are. But it turned out that this function was publicly callable by anyone. And so you could just call it and say, you know what, I'm the owner, and then you spend the funds. And this is because, and the reason this bug happened is that because by default, functions with an entry point, functions which are not marked otherwise are public entry point. Whereas the secure way of designing this was like by default you are a private entry point. Because if you do deploy, you deploy your contract like that, maybe it won't work, but you won't like lose your funds like this. So you won't, at least you won't even compile when you try to change the owner. So this default is a problem. Or one thing you can do in Solidity, you can say like var a equal 1, var b equal 2, and then do 2 minus 1. And I think it will be like, I think it will be something like 255, because if var a equal 1, it will pick the smallest integer type that it can find in order to represent it, which is an 8-bit integer, and it will do both, and then it will do a conversion. So, in essence, that's not a really good property to have. In Michelson, for example, integers are arbitrary precision integers. They're not machine integers. So it's less optimal because it's not running on the CPU anyway, right? So there's no sense in trying to have like a data type that matches exactly what the CPU is going to run when you're running a high-level contract that is supposed to be doing business logic anyway. So I think that's some of the differences in how we approach it.